Hello friends, this is lesson 3 of NLP, Natural Language Processing. In today's lesson, we are going to cover the following topics. So first we'll be discussing what is NLTK, then how to install NLTK, and then we have some basic operations using NLTK, simple statistics will apply, and then we'll end up with looping and conditions. Now let's start with the first topic and see what is NLTK. So NLTK stands for Natural Language Toolkit. It is actually a Python interface which is used for text processing. So just by installing this interface using Python, what will happen? It has many built-in libraries, functions and packages, and using those functions and libraries, and we will be able to build a model that can understand human being language and can provide an appropriate response to that. So we got that it is an open source Python interface used for text processing with different built-in libraries which are used for tokenizations, stemming, we have tagging, chunking, parsing, classification, language modeling, and we have logical semantics, and so many other libraries or their built-in libraries and packages. We can import those packages to our program, and then we can utilize the functions, and you can utilize the libraries, the packages for building the model which will be able to understand human being language and reply to it with an appropriate response. Now let's see how to install this NLTK. For installing NLTK, first we will be opening the terminal. So Ctrl plus Alt plus T, if I press here I have the terminal. So then for the first step, what we have here is sudo apt. This one we have to update the list of packages first, and for doing that we have to run this command, and it is asking for the password. We just provide the password. It is updating the list of packages. Then after that, the same command what we use for installing Jupyter Notebook, that we'll be using, which is called pip3 install. Instead of Jupyter, we'll be using NLTK. So I take the copy of this, Ctrl C, and paste it here. Yeah. Now the next step is we have to type Python 3. Friends, for me it is already installed there. It is just updating the files, but for you it will be taking some few minutes for installing that. Now I'm typing here Python 3. Now I'm here, I have to type this one, import NLTK. So I'm writing here import NLTK. It is installed and it is not giving error, so it is imported. Now I'm using NLTK dot download. So just by doing that, here we have the interface, and from here we can install the different packages what we have here. Corpus or their models or their all packages. These are the all packages if you are familiar good with, so you can install manually. Otherwise, if you don't know, you come to collection, and from here you can just install or you can select this one all and then press download. It will be downloading and installing all the packages for you. Since I have already installed, I'm not installing, just showing you how to install it. So you just click on all and then press download. It will be downloading and installing all the packages for you. I will close this, and here again I will press Ctrl Z and exit. Okay, so the next topic is here, some basic operations using NLTK. So we understood that how to install NLTK. NLTK is already installed there. Now the first operation what I'm going to do is here searching a text. How to search a text, but this is not searching the same as what we did in string. Here it will be searching a text along with the context, friends. how many times the word is used in the given context. So for that we will be calling this function concordance. If you are calling this function, so you just type the string here what you want to search, it will be showing you the result, how many times it is repeated in the given context, right? And then we have similar text. Similar text is used to check the similarities, closest words to the word of interest. Just you call the similar function. This is similar function from the text, and this text comes from the NLTK. You have to remember, friends, this one comes from NLTK because we have already installed that. And then this one is user defined. We can type here the string what we want. Then we have the common context. So the common context is, this function is actually used to show us which context is shared between the 2 or 3 or many strings what we put here. So here I have put string 1 and string 2. This function will be checking what is the context common between these two. So for that we will be using this function. And then we have another function called generate. It is generating random text from a given text. So if I give this text and then call this function, it will be generating different text from this one. And then here we have simple statistics. If you are applying statistics, the first step is to tokenize the sentences or the text. And you know what is tokenization? We said that splitting a text into tokens, and we said token is not equal to word, if you remember in previous lecture we talked about. Then frequency distribution. So this frequency distribution is actually used to check how many times a text is repeated. And then we have fine-grained words selection, like based on condition. For example, if you want to select the words based on size or number of characters which it has, so that is called fine-grained word selection. How many characters are there based on the length of that. So like that. And then we have collocation. What is this collocation in bigram? So a sequence of words that usually occur together and can also be replaced with words with similar sense. Like we have every day, we have tasty food, we have delicious food, and we have every night, Mr. John. So these are called collocations, right? Now let's see practically all these things and you will better understand. I will just open the Jupyter notebook, and I am importing first NLTK. This is the first step you have to do, import NLTK, right? So just pressing shift enter, yeah, it is imported. And then from this NLTK I'm just importing the book. There is a package called book, and within this book we have different texts, and we can use those texts for practice purpose. You see here, friends, we have text 1, text 2, text 3, text 4 up to text 9, and also we have sentences, multiple sentences like sentence 1, sentence 2, sentence 3 up to sentence 9, and they are already tokenized. Just we are importing them and use them for practice purpose, right? Let's see the first one. Let me show you some of the text from them. I will create another seal here and I will show you like sent 1. Let me see what is there. So it is saying call me Ishmael, and this is a sentence, sentence 1. You can call sentence 2. What do we have? And this is the text of sentence 2, and they are already tokenized, right? So they are sentences. If you go to like text, again here you just type like text 1. Yeah, this is text 1, and there are so many words are there. Let me show you that. Let me print some 10 of them. So you see, these are the words within this text 1, and you can increase the numbers, like for example let it be 40, and we have these things here, right? They are already tokenized. You can change like that, text 2, and you can put here up to text 9 if you want to see the contents, right? So now let's see here and apply the first operation, which is called searching. So searching, we said keyword in a context. How can we do that? And for that we have to call this function concordance. So this concordance, well, it is not like searching a string, it will be searching a text along with the context. For example, I want to search this man, so this will be showing me the context also. The man is here, the left side context we have this, and another we have the right and left context are there, right? And here how many times it is repeated, here it is showing me along the context. For example, if you're typing here book, let me see whether book is there or not. Yeah, it says, yeah, one match is here. It says, okay, in the name of Lord. Here it is repeated along with the context, right? So for that, we will be using this function and using the text from NLTK. We have another function here, similar. So similar is used to check the closest words to the word of interest. For example, I want to see man, similar words to this man. From which text I am reading? From text 9. It is saying these things are along the context it is coming. Like we have policeman here, so we have president, like we have professor, and so many like gentleman. Along with the context, it will be printing the word what we are searching. And then we have common context. We will be seeing here these two strings. For example, here these two strings, I want to see whether these two strings are sharing any context within this text 9 or not. Just we'll see. Yeah, they are sharing some text, and these are the text shared by them, the context. And then we have the generate function. So generate function is generating the text randomly. For example, if I see text 1 and from that I want to generate some randomly some text from text 1, I will be using generate function. So see, generate, it is generating randomly a text from this one. You can give some other names also, text 2, text 3, text 4, like that. It will be generating randomly the sentences and the text from that, like this. And then let's see here simple statistics. And for doing simple statistic like finding the frequency of words, how many times the word is repeated, like that. So first of all, we have to apply tokenization there. Tokenization means splitting a text into words. For example, this is a sentence, right? If I want to apply or count the number of words, how many times each word is repeated, first I have to tokenize this. But if you are using these examples, they are already tokenized. You can just give the name and you can apply the functions there. But if you are using your own text, the first step is to normalize and tokenize the text. So for doing that, I will be calling a function here, word tokenize. And this word tokenize is a function within this NLTK. That is why first we have to import NLTK, and from NLTK we can call the functions. Let me execute this part and you can see it is tokenized. This is the first token, second token, third token, and this period is also considered as a token. Here the last one, right? And then if we go to like here from text, they are already tokenized. I want to print from 0 to 100 of them, you can print them like this. So these are the text within this one, text 1. The tokens, what do we have, right? So I have converted it to set. Here you see that it is converted to set. Otherwise you can remove this also. If you are removing it, it will be not showing it within the, yeah, it is now a list. So the list is ended here, and here we have, and this is showing me the first sentence there. Then again we have like this, so many brackets are there. Now let's see here frequency distribution. So frequency distribution, as I mentioned there, it is used to count the number of words, how many times a word is repeated there. If I give the same example, the man took the book, because it is tokenized now, we have to tokenize it. Now if I press this, it is showing me that is repeated once, the man is repeated once, took is repeated once, and this that is also repeated once. Why we have two the article the, then why it is showing me one, because this one is different from this one. They are both, this one is in capital letter. Let me change it to small, and then if I execute, I will be seeing this result that is repeated 2 times, and then we have man like this, right? So instead of this text, if you are using NLTK text like text1, and the number of tokens what I want is 50 tokens, and I want to see how many times they are repeated each word and item. So see, this bracket is repeated once, and this comma is repeated how many times? 3 times, and this one is repeated. So it is showing me all these things, how many times they are repeated. Here I have put items, and said you can put like keys also if you want. Different functions are there, only the keys or items, or you can see the values. It will be showing you like this. If I put the items, so it will show me the items like this, the item and its frequency, how many times it is repeated, distribution frequency. And now if you want a single word, like for example here, this word, how many times it is repeated, a specific word. So for that you will be calling this frequency distribution what we created there. This is created, it is object of text1. So within this one I am searching a specific word called this one, movie. Let's see how many times it is repeated. It is say it is repeated only once. Let me show you some other. Let me take this one, buy. So buy, you know, it is repeated how many times? 2 times. Whether it is showing me or not, yeah, it will be showing that. Yeah, it is showing it is repeated 2 times. So there are so many other functions also, friends, not only these, so many other functions. I have listed only few here. For further you can read the book. In the book there are so many functions, like for example this function, if you put n, so this one is total number of samples, keys as I used before there, maximum, tablet, we have plot, like this we can use. Let me use some of them here. Like I say this distribution 2, and I use max here, which token is repeated the most. So it is showing me this one is repeated mostly. It was there, if you remember, it was repeated 3 times, the maximum, right? And instead of this you can use other functions like keys, as I used there, keys, these are the keys. You can use like for example n, total number, because we said 50 if you remember here. So the size is how much? 50, right? That is showing me that 50. You can like convert it to keys, numbers, frequency of a specific word, as we use their movie, like that. You can plot them here, just like saying plot. It will be showing us the result in the form of graph like this, right? In here we have, these are the frequencies, the counts, how many times they are repeated. In here the words are given. You can change the numbers, like let me take 20 of them, then it will be less number of words. We have only 20, and then if you come here and press this, so the numbers are reduced, and you can easily differentiate. This one is by how many times, and this one, each and every one. And you can also use this one, cumulative. If you are using cumulative, it will be showing you cumulative graph like this, friends. It is showing how many times each word is repeated. So many others are, like for example, if you want to convert into a table, right? Tabular form. I will be using this one, tablet. It is showing me the word and its frequency, how many times each word is repeated. Let me put here maximum, right? This one is repeated the most. And now let's see here, fine-grained word selection. Now based on condition and based on, like for example, if you want to see how many times a word is repeated, or how many like based on number of characters, the lengthy words, if you think that the lengthy words are more informative, so for that you can be using this one also. So like here I'm using text1, right? It is converted to set, and then I say long words. Which long words? I'm reading long words from word and tokens, and then I put here if the length of word is greater than 15. I don't want all the words, only the words whose length is equal to or greater than 50. And how many of them I want to print? 20 of them. You see, these are the words with length of greater than 15. You can change like 20, whether we have 20 or not. Let me see. We have only one is here, right? If I put like 15, 10, since for 10 we are having more, since I have put here limit, it is showing me only this 20. If you put like 100, so we have so many words whose length is equal to or greater than 10, right? And then we have, for example, another condition. You can put like the words token word is equal to, like say length is equal to or greater than 10, and at the same time the frequency, distribution frequency of word is greater than how much? 15. So let us see this. We don't have that. Let me change this one then. Long words, or okay, it is used here. Let me change this to 50, and we will be having more number of words or tokens. And now here, right, okay, say print word for word in tokens, and this token is here. Tokens will be reading the text from text1, and here why it's not showing me words in tokens. If word is equal to or greater than this one and frequency is equal to 15, let me change that to 10. Okay, and let it be 1. Okay, let me remove this and see. Yeah, we have these many words, and instead of that you can use like other things, like if you want to count the words which starts with EP, Control C, I will put it here. At the same time I say the word which starts with EPP, you show me only those words. You can see that these are the words that they are started with EPP, or you can say which ends with LY or any other characters, you can put it there. So you just put here like this. You see, okay, word dot ends with that, right? So these are the words, you can see they are all ending with LY. And again, if you come here, collocation we have. What is this collocation? Collocation, a sequence of words that we said usually occur together, like we say Mr., the person name, or tasty food, every day, like that. So from text 2, I want to see the collocations. Let's see. Yeah, these are the collocations we have. Young man, combi, this one, every day, next morning. These are called collocations. Sometimes we may need or decide based on collocations. And then here we have loops, friends. About loop we already talked in previous lecture, but some examples I want to use from these texts from NLTK. So we can use different relational operators here, like greater than, equal to, not equal to. These operators you can use and filter the data. For example, I say word from this sentence, I want to print the words whose length is greater than how much? 5. I want to filter only those words. So it is showing me these are the words. You can change this here to 4, 5, 6, 7, or instead of greater you can put less than, equal to, not equal to, like that. Let me put like here not equal to 5. So then we have these things. 5 is not there, so the remaining things are there. For example, equal to 5, only 5. So we don't have like that anyone, right? If you put greater than or equal to, then we have some words. These are smaller than. And at the same time, if you want to use string functions like start with, ends with, as we did before, you can also filter the data using the loops. It is actually a loop within a list. So see here, for word in sentence 2, if word starts with s, it is filtering those things. You see, this is the result. And again here we have loop, and within this loop what I am going to see, I want to see the length of each and every word within this sentence. So it will be finding the length of each and every word from this sentence too. You see how many words are there? These many words are there, and this is the length of first word, length of second, length of third one. And instead of that, you can use another function here to upper. I want to convert them all to uppercase. So they are all converted to uppercase. Instead of this, you can use lowercase, and they are all converted to lowercase. So these were some of the functions what we applied and used from NLTK. So I showed you how to install this NLTK and how to import the text from NLTK, and then you can practice these functions like for searching, similarity if you want to see common context, generate randomly text from those texts, and then we apply some statistics here, like we count the number of words, the length. We created our own example here, or you can use the text from NLTK. So I hope you all understood these things, friends, and we discussed these topics what we promised. Thank you, friends.